Hi students, now we are going to discuss about Wurtz reaction, WURTZ. This is very important reaction for class 11th, class 12th students and different competitive examination students. Yeah, it is a important topic we can study under preparation methods of alkanes and also in the second PUC, that is class 12, under chemical properties of alkyl halides. Yeah, let's start now. Yeah, alkyl halides, for our convenience, we will discuss this one under three subheadings. That is, first one is simple Wurtz reaction. Second one is cross-Wurtz reaction. And the third one is internal Wurtz reaction. What is a simple Wurtz reaction means here? The Wurtz reaction takes place between the two similar alkyl halides, right? So for example, take here one general equation we have explained. The alkyl halide Rx, we have to take 2 moles, react with 2 moles of sodium metal in the presence of a dry ether solvent or in the presence of tetrahydrofuran solvent or in the presence of dioxide solvent. Right. This is a electro solvent. The solvent which is not participate, not involved in chemical reaction. Right. Now unheated. Now what happened here? This is sodium combines with halogen, removes as NX, and 2 alkyl groups are combined. We will get RR and 2 moles of NX. This is called 2 similar alkyl halides are there, alkyl groups are there, methyl, methyl, so ethyl, ethyl like that. So that's why it is a symmetrical alkene. If you cut it, you will get 2 equal halves, right? Okay, through the bond. So this is called symmetrical alkanes you will get. That is called even number of carbon containing alkanes. Even number of carbons containing higher alkanes you will get. Right? Fine. This is the general equation. By using this one, we can prepare different examples. Maybe the place of alkyl group, we take maybe methyl group or ethyl group or N-propyl or isopropyl or butyl, anyone, right? You will get different examples. First of all, take one carbon, that is CH3 methyl iodide. You have to take 2 moles of methyl iodide, react with 2 moles of sodium metal, and it is heated by using the dry ether solvent. Then what you will get here, with the removal of this sodium iodide, the 2 methyl groups are combined, you will get CH3, single bond CH3, that is C2H6. You will get ethane, you will get with the removal of 2 moles of sodium iodide. Is it clear? Yeah. We take one more example. We take for example ethyl group, CH3, CH2 bromide, ethyl bromide. 2 moles of ethyl bromide react with sodium metal, the presence of dry ether as a solvent. Then it removes sodium bromide and this ethyl group combines with this ethyl group. Then we will get 4 carbon alkane, there is C4H10. There is butane you will get by the removal of sodium bromide. Right. Is it clear? Okay. Here we observe one thing, my dear student. Here 2 carbons are there in the reactant, but the product 4 carbon atoms are there. There is double the number of carbon containing product we will get. Double the number of carbon containing alkane we will get. That means the final product containing more number of carbon atoms than the parent alkyl halide from which it is prepared. Yeah. Fine. Yeah. Next one. This is a simple Wurtz reaction. Then we will go for next cross-Wurtz reaction. Second one. The cross-Wurtz reaction. If the Wurtz reaction takes place between two dissimilar, two different alkyl halides, then we have to call it as cross-Wurtz reaction. The cross-Wurtz reaction, take it here, are two different alkyl halides. For example, take it here, this is R and R dash. Okay, that is both are different. That is one mole of alkyl halide Rx, other is R dash X. So students here, this R and R dash both are different. R is not equal to R dash 1, but here both are alkyl groups are same. R is equal to R dash. But here, methyl, it is a ethyl, the cross-Wurtz reaction, or maybe ethyl, propyl, like that. Two different alkyl halides. Okay, then it is heated in the presence of dry ether solvent or tetrahydrofuran. Then what you will get here, you will get this R combines with R dash, or this Rx, 2 moles undergoes self-Wurtz reaction, 2 moles are combined this, you will get RR, or this R dash X, 2 moles are combined together, you will get R dash R dash. You will get 3 products will get made straight and removes as NX. Okay, 2 moles. Then this is the general equation. Okay, we will take one example. Take here, it is a 1 carbon methyl iodide is react with 1 carbon methyl iodide react with, take it here, 2 carbon methyl or ethyl iodide. It is a 2 carbon CH3CH2I ethyl iodide. These two combines in the presence of sodium metal and heated by using the unit solvent or tetrahydrofuran or dry ether. Then what you will get here, this methyl group combines with this ethyl group, these two. Okay, then we will get here, we will get here this methyl group combines with ethyl group, that is C2H5, or this methyl iodide 2 moles undergoes self-Wurtz reaction, you will get ethane, or this ethyl iodide 2 moles undergoes self-Wurtz reaction, you will get butane. Okay, right. Yes. Now we will get 1 mole of propane, 1 mole of ethane, 1 mole of butane. Okay. We are getting here different alkanes we are getting now. It is very difficult to separate them. Why? Because all these have similar or closer in their boiling points. That's why this are all we are getting here different alkanes. And it is difficult to separate them. Difficult to separate. Why? Because they have similar or closer boiling points. They have closer boiling points. So that's why it is very difficult to separate them. Okay, is it clear? That's why we are getting here unsymmetrical. If you cut it through this plane, you immediately get 2 equal halves, right? Propane. You are getting here unsymmetrical alkanes, that is having odd number of carbons. So you are getting here unsymmetrical alkanes containing odd number of carbon atoms. Odd number of carbon atom containing alkanes we will get. Got it? Okay. Right. That means in a simple Wurtz reaction, we are getting symmetrical even number of carbon containing alkanes. In a cross Wurtz reaction, we are getting unsymmetrical alkanes, odd number of carbon containing alkanes. Okay, keep this point in your mind. Next one. That's why this cross-Wurtz reaction is not much practice to prepare unsymmetrical alkanes, because you will get different alkanes. It is very difficult to separate them. Fine. Yeah. Next, the third one is internal Wurtz reaction. Internal Wurtz reaction. Right. What is internal Wurtz reaction with here? Internal Wurtz reaction means the Wurtz reaction is take place within the same molecule, only one alkyl halide. For example, you take here the butane, right? And here in the butane, here one chlorine atom is there, and here one chlorine atom is there. 1, 2, 3, 4. This is a cyclobutane, and first carbon, third carbon position chlorine atoms are there. Cl. 1,3 dichlorocyclobutane. 1,3 dichlorocyclobutane. Right. So this compound, it is heated with the sodium metal, the presence of tetrahydrofuran or dioxide as a catalyst, or we can use a diethyl ether, that is ether. Et means ethyl one, diethyl ether. Okay. Anyone you can use it. The presence of any one of these solvent on heated, then what you will get here? You will get like this. Here this chlorine atom and this chlorine atom, both are there in the same molecule, right? So this is first carbon, this is the third carbon. Okay. This sodium combines with this is sodium atom. This is sodium atom. Right. It combines with this, so it takes away the chlorine atoms. Right. Then these two are connected together through a bond. We will get here this one. You will get this is a bicyclo compound, right? Okay, bicyclo. The compound name is bicyclo. Bicyclo. Here there is 0, 1, 1, 0, right? 1, 1, 0. Cyclo. Bicyclo. Here 1. This is 1, and this is 1. This is 0. Butane. Butane, right? 1, 2, 1, 2, 3, 4. Okay, got it? So we'll get, this is the product we'll get. This is within the same molecule, Wurtz reaction is take place. Then it is called internal Wurtz reaction. Internal means the Wurtz reaction which is take place within the same molecule only, right? So here the chlorine to chlorine atom, for our convenience, like this you didn't get in the books. I just explain like this. It is very easy to understand, my dear students, right? So here this chlorine I just represented here. This sodium takes away these chlorines. Then these two are connected. You will get a bicyclo compound, right? Okay. So this is a previous year IT examination question on APMD question. Okay, fine. So this is internal Wurtz reaction. Then, so some more concepts are there, and some what are the limitations of this Wurtz reaction are there. Okay. So first of all, copy these things. Okay, take a screenshot. Okay, can I erase it now? Fine. So what are the limitations of this Wurtz reaction? And then what is the uses of Wurtz reaction? And what is the mechanism of Wurtz reaction? And there is two types of mechanisms are there. And then some previous year questions that we will do the next video, my dear students. Okay. Is it clear? Up to here, is it clear? Fine? Yeah. So I think you enjoyed my video. If you like it, subscribe it and share it to your friends. Thanks for watching my video, my dear students. Yeah.